Hi, everybody. Welcome to Science Around Town, episode number 2. I'm Ryan Hollister, the secondary science coach for Turlock Unified School District. So today, I hope you'll join me as we try to give this amazing piece of artwork that's somewhere in Turlock its day in the sun. Most everybody seems to walk right by it without giving it a second glance, and nobody really understands what it is. So hopefully after you watch this, you'll have a better idea, and you can also build a model of one at your house. So our adventure is going to begin here, right here at Monte Vista Crossing, which is right where the home of Target and Starbucks and Panda Express and all that stuff is. And right in the middle is this beautiful sculpture. So it's on the corner of Monte Vista and Countryside Drive. And if you zoom in a nice camera, this is what the sculpture looks like right there. So as a scientist, I'm always curious to try to figure out what are the pieces that make this thing, and maybe those pieces can give me a clue as to how it works or what its purpose is or what its function is. So I happened to go home and grab a 360-degree camera, a small one, and stuck it on a long pole so I could get it as close to this orb as I possibly could to figure out what's it made out of and what does it do. So I noticed that some of the components were that it was made out of metal, and it looked like it had 3 separate rings, a big ring on the outside here, a big ring like this, and then another ring that seemed to be made out of a different metal, not quite as shiny as the other stuff. It looked like it was anchored into the ground pretty sturdily with concrete. And then I also noticed there was a bar running between these 3 rings that when they were all put together kind of made it look like a ball or a sphere. And I also noticed that it looked like there were some numbers or something on this ring, but it wasn't quite a good angle, so I went to the other side, and here's the same sphere, but on the other side, and sure enough, I was able to tell that there are indeed numbers written on here. And those numbers are Roman numerals. They go from 7 to 8 to 9 to 10, and then it gets a little out of view, but I can tell you based on what I saw from the other side, is it goes down to 12, and then it starts over at 1, 2, 3, 4, 5, 6, 7. So, the only other thing that I've ever seen that starts over at 12 is a clock face, which got me to think that this must be a clock. But I took a closer look, and there's nothing on here that's motorized. Nothing moves, it's all welded, it's solid. So if it's a clock, how does it work? And then I realized, oh, I know what it is. It is, and let me get by here, it's a sundial. And so basically a sundial uses the sun and the shadow cast by a certain object to tell the time. And it turns out that this is a special type of sundial called an equatorial sundial. I'm going to move myself over here so you can see. And this equatorial sundial is pretty cool. And it has 2 components that all sundials have. And the first component is something that makes a shadow, and that's called a gnomon. And so the bar in this sundial is called a gnomon. It's the shadow maker. And then it has what we call a dial plate. And in this case, the dial plate has all the numbers on it that the shadow gets cast onto. It kind of catches the shadow, if you will. And whatever number the shadow hits, that's what time of the day it is. And it turns out that in this case, the numbers are welded in like this, but a lot of other sundials have just a nice flat plate of stone or something that numbers are scratched onto. So we have a gnomon and we have the dial plate. And it turns out that this is an equatorial sundial to take advantage of a really slick trick here. And that is, we know that the Earth spins around its axis once every 24 hours, right? It rotates, that's one day, 24 hours. And we also know that it's 360 degrees around a circle. So if we do a little bit of quick math, 360 degrees divided by 24 hours means that the sun, or the Earth, I should say, rotates about 15 degrees for every hour. So 15 degrees per hour. And so what we're able to do with sundials is take advantage of that information and that math and space out numbers on our dial plate at 15 degrees on these equatorial sundials. If we space the numbers out at 15 degrees, that means it'll take 1 hour for the sun shadow cast by the gnomon to move from one number to the next, to the next, to the next. And it's not like the shadow just disappears in between each number. It's there, but when it hits the middle of each one of those numbers, that's the exact time of day. it's a pretty slick way of telling time. If you wanted to get down into the even nittier time movements, basically we move 1 degree every 4 minutes as the Earth rotates. And so as the Earth rotates, it makes the sun above, even though it's staying in the same spot, it makes the sun move across the sky as the Earth rotates underneath it. And we take advantage of it by casting the shadow on different spots of the sundial. So the big picture, how do we get an equatorial sundial to kind of work? If I were to take that sundial from Starbucks there, Monte Vista Crossings, and do a bad Photoshop like you see here in this image, and made this really big, like a size of the quarter of the Earth or so, and blew it up and put it right at Turlock's latitude, this is what it would kind of look like from space, where the gnomon is actually angled and pointed and aligned with an imaginary line between the north and the south pole of the Earth. And what happens here then is the dial plate, when it goes perpendicular to the gnomon, or when it makes a right angle, it comes in at a cross like this, it allows that plate to be parallel to the equator, which is a big deal and helps keep the shadow equal, or the shadow's movement equal over that 15 degrees the whole entire time. So the way we do this with all sundials here is you have to tilt your gnomon at the same angle as your latitude. And it turns out that Turlock is right at 37.5 degrees latitude north. So it's 37 degrees north of the equator. And once you arrange that at 37.5 degrees north, then you have to point the stick, the gnomon, to the due north. So you want to point it towards the North Pole. So you have to raise it off the ground 37 degrees and then make it point towards the North Pole. Absolute north. Compasses will mess up by about 10 degrees or 12 degrees here in Turlock, so you have to calibrate for that. But basically, tilt it north, or tilt it at 37.5 degrees up, point it north, and you can make any sundial work. And so if you take a look at this image, this is what we see again. The gnomon right here, if I were to take a measuring device like a like a level, or if I took a protractor and I measured the angle here, this gnomon is sticking exactly 37.5 degrees above the plane of the ground. And it's pointed, you guessed it, due north. So because it's pointed due north and because it's tilted at 37.5 degrees, it tells the time every hour almost perfectly. It varies by about 10 or 15 minutes during the different seasons, but it tells it almost perfectly day in and day out as long as there's sun. Obviously, it does not work if there's clouds or rain or no sun or anything like that. So that's what it is. It's a sundial, which is pretty cool. And so in California, there's lots of really neat sundials. My other favorite one happens to be one of the largest sundials in the world, and that's this bridge up in Redding, California. It's about a 4-hour drive north of Turlock or so, but the bridge is one giant sundial. It's not quite an equatorial sundial. It's called a horizontal sundial, but it also tells time. And I happened to be there right around the summer solstice a few years ago, and was able to catch the shadow right on the dial plate right there at about 1:15, which is pretty cool. So I highly recommend going up there and seeing that if you ever get a chance. So one of the other cool things that some folks have started to make are digital sundials. Oops, let me see here. I 3D printed one of these digital sundials as well, and instead of casting a shadow on a number, somebody was able, that was very smart, was able to trace the rays of the sun and predict where they would be in order to make a digital display, which is pretty slick. And so I won't quite show you all of how the 3D printer works here, but it spins around, it prints it out, and then once you're done, you get a nice sundial that looks like this. And if you were to speed it up over time, it changes every 20 minutes as the sun goes through different slots and lights up different holes, which is pretty slick. So those are some of the other cool sundials. Now, wouldn't you love to make your own sundial? I hope so, because I put some links on here so you can do that. So how can you build your own sundial? Well, once we get back into town here, I'll show you. You have a couple of different options. You have one option, which is called the easy horizontal sundial. So this one, basically, all you have to do is cut it out. And once you cut it out, you fold where this line, and this line, and it makes a gnomon that sticks up. But if you notice, the numbers are not equally spaced out at 15 degrees. And that's because we're not making the dial plate be aligned with the equator here. It's flat on the ground. So that's one way to make a good, easy sundial. The second way here is the easy equatorial sundial. And basically what you do with this is you cut out the top and you cut out the bottom and you glue them together and you stick a stick through it and you make sure the stick is angled up at about 37.5 degrees. I'll show you how I did that, how I've calculated that in a moment. But once you do that, stick it in the ground and then the shadow will cast the time, which is pretty awesome. The next little bit more advanced version is this guy. And so you cut on the dotted, the really small dotted lines there, you cut out on those, and then you cut out the gnomon here. I have included in this virtual experience here, here's the finished results of what each one of those 3 different sundials looks like. Here's how you can tell which way is north. You can use the compass on your phone. And then I use the tilt meter in my phone. It's like called Apple Measure, or Androids have other devices too, but it basically will calculate the tilt of your phone. And if you put the stick on there and lay it flat on top of the screen and then move the phone up and down to the right angle, you can place it so that it's pointed directly at the North Pole and in line with the celestial axis there, which is pretty slick. And there's a time lapse of all the constructions or the instructions on how to construct it and make it right there. So I hope that you found it very interesting and enjoyable, that indeed that cool sculpture that is sitting behind me here, this is an amazing sundial that nobody knows exists. So go check it out. And oh, by the way, it's daylight savings time, so it'll be off by 1 hour at the moment. So there you go. It works year round. Next time you're out there in the sunshine, socially distancing, check it out and be amazed. See, we gave it its day in the sun.